Welcome back. Today we're going to look at density. We're not going to do any density problems here. I'll do those in another video. But let's look what density is. So density is the mass of the object or the material or the substance divided by its volume. Divided by its volume. So when you look at density, and mathematically, density is going to equal the mass divided by the volume. If you're in a lab or anything, doing a lab, mass is going to be done on a balance, and the volume, there's going to be two different ways you can do the volume, and we'll look at those in just a second. So when you think about density, it's really a property of the object, because as mass increases, as mass of the object increases, so does its volume. So does its volume. So therefore, the ratio does not change. So the ratio remains constant. So when you think about density, it's really a property of the object. And seeing density doesn't depend on the amount of the object. Density is considered an intensive quantity. Density is an intensive quantity. And is a property or a physical property of the object. When you look on the periodic table for properties, they're going to give you the density of the material, they'll give you the melting point, boiling point, and some of those things. But density is a quantity, intensive quantity, and it is a property of the object. So density is not going to change. Density of gold is like 19.3 grams per milliliter, and so forth. Well, let's look at the units. So density is really a derived unit. So if we look at that, we use two SI units, and the SI units used are going to be mass, the units for mass, and volume. The standard SI unit for mass is the kilogram. Mass is the kilogram. And the unit for volume in the metric system, the standard unit, is the cubic meter. So density, if we were to use these two, would be kilograms per cubic meter. Well, the problem with this, excuse me, is that kilograms and meters are way too big. So typically what you're going to see, or more commonly used, are going to be the common used units common units are mass is going to be grams, and volume is going to be a cubic centimeter or its equivalent in milliliter. Those are the two that are most commonly used. When you have a solid, typically you're going to see cubic centimeters if it is a regularly shaped object. If not, you might see it done in milliliters. And we'll take a look at that in just a second. Now for a gas, gas is so light. Now let's adjust this once. Gas is so light. So for gas, typically you're going to see the units of a gram per liter. Now you get into density problems with the gas, those are typically going to be your units. Now for a regularly shaped object, let's say for a box or something of that order, for a regularly shaped object, what you're going to end up seeing for a regular shaped object you're going to use length times width times height. So a centimeter times a centimeter times a centimeter, and that'll give you a centimeter cubed, or cubic centimeter. Now, if you're in a lab and you're just doing an introductory density lab, you probably have a block of wood or something like that, and you can measure length times width times height. For a irregularly shaped object, you're going to use water displacement. So for an irregular object, typically what you're going to use is water displacement. Oh, you sit in a swimming pool or a small swimming pool or a tub. Once you get in, you can notice that the level of water rises. Well, the same thing can be used to determine the volume of, let's say, a little stone or a rock. And quite often what they're going to do is give you a problem, and you're going to have a graduated cylinder. You're going to put in a known quantity of water. Now let's just say we got 30 milliliters. And you're going to drop in an object. Let's say you put a rock or something like that in there. Let's see if we get a different color going here. So put a rock in, and the water level goes up to 35 milliliters. So once you start with a known volume of water, put your object in, and the water level is going to go up. So the difference between the two is going to be the volume of your object. So 35 milliliters minus 30 milliliters is going to give you a volume of 5 milliliters. Now you got to remember, a cubic centimeter, cm, and milliliters are equivalent. And you're going to see density in either one. All right, so we're going to call it good there, and then we're going to come back in the next video and actually do some problems. So until next time, we'll see you later.